What is up, everybody, and welcome to the Data on Kubernetes community. Super stoked to be here. We are almost at live stream number 140 since we got started about 2 years ago, about to celebrate our second anniversary in July. That being said, extra excited to be here. That's why I got my sunglasses on, blinded by the Data on Kubernetes community lights. That being said, very important announcement before we bring our amazing speaker for today. We've got something coming up. All right, we've got the next DoK Day. All right, it's going to be on October 24th in Detroit, and you can send in your CFP already. I was talking to today's speaker, Yaniv, about this actually, and we've already got folks sending in their ideas. So you can do the same thing. As usual, we want our talks to be end user focused. Right? We don't want to hear just people trying to sell something. This is not a sales event. This is an event for engineers to make running data on Kubernetes easier, to standardize practices, to get all that good stuff in there. Bring your customers in, bring your end users in. This is who we want to be hearing from. Also, if you're going to give a talk alone, why not invite somebody else to give it with you? And why not somebody from an underrepresented group? All right, we did a panel about DEI not that long ago, really hitting hard on these topics, trying to get more folks into the fold when we're talking about data on Kubernetes. So please keep that in mind. Like I said, you've got the link right there to Sessionize. We'll be promoting this. You can expect videos, all that kind of stuff in lots of different places to get all these things delivered on time. And speaking of delivery, today we're going to be hearing a lot about delivery from a person who has been delivering software since he was 10 years old. Many people's first job is delivering newspapers, but today's speaker, Yaniv, who joins us from Israel, Tel Aviv, small town you may have heard of, he's been developing software since he was 10. And now he's working at a really cool place, memphis.dev, that you should definitely check out. You will be checking out. Yaniv, turn on your camera and show yourself. What's up, man? Perfect. Like magic, he appears. How are you doing today?
I'm great. It's hard to come after such a cool intro as always, Bart. So thank you.
Everybody, you're doing good. Now tell us really quickly, what's your backstory? You started at the age of 10. Now you're in the Data on Kubernetes community. You probably did not imagine at 10 that you would be talking to me later in your life. So lucky you. But regarding that, how did this journey get started, and how did you get to where you are right now?
So I thought about it, and I remember this story just not too long ago. I've received an HTML book, like an old HTML book, when I was 10 years old from an old neighbor in my building, and there it started. I thought I was about to become a lawyer, and then I decided that my true passion is development, actually, and there where my journey started, and I've been developing ever since. Try to learn as much as possible, and constantly evolving and joining different communities, and hopefully bring some value with the stuff I built. So that's where I started.
Good. And how about your Kubernetes journey? How did that start?
So it started on 2019, actually, when I first, by the way, I've been in DockerCon in San Francisco, and I've first got to know data on Kubernetes on DoK Day, where I saw you with your guitar, and thought about this is a cool community to join, taking things easy and light. But actually, I've never thought that I would be able to actually participate in the community. So I'm really happy for this opportunity and excited.
As we are too. Good, very, very good. So we've got a little bit of info here about the kind of app we're going to be looking at. All right, we all are used to having things delivered. Maybe some people probably aren't as conscious of all the technology that's behind that. In order for things to be coming in real time, we can talk about scalability, we can talk about high availability, we can talk about different things that are going to get in there. But this whole idea about building a stateful Doordash style app, what can we expect from today's talk?
Definitely. So the application itself was not meant to be really complex or branched. It was meant to pass the topics that I wanted to discuss about to become more event-driven, more real-time, to bring more real-time architecture in your app and on top of Kubernetes. So those are the subjects that I wanted to address by building this app. And I thought to myself that using a cool app as a demonstration for those for those topics would be a good way to emphasize it.
All right. Well, that being said, if you want to share your screen, take it away. Folks, if you have questions, please get them in the chat. And for those of you who are watching this in the future, you can always interact with Yaniv on Slack. He's very responsive, easy to talk to, as you can see. So that being said, if you want to start sharing your screen, jump right into your presentation.
Definitely.
Good.
So I stopped share. I started to share, right?
Yep.
All good. Okay. So super excited. Help me out if I get stuck sometime. Really happy to have this opportunity to engage with the community, with the users and the users of DoK in particular, and explain some of the subjects that Memphis in particular touch and me as a developer, or at least a former developer, or always a developer, think that we should become more and more focused in the coming years. Data streaming, event driven. We should definitely cover this one on this workshop. So and I thought to myself not to take it too hardcore with the deck, just go over the article. Hopefully people will join with me and do some stuff along the way. That's it. So I think that we should start by understanding why I chose Doordash and what does it mean for me, event driven, why this is important, and why the subject is so I would say so important for the era that we are in right now. So event driven means that something happened or some event occurred somewhere and it triggers an event, and that event and it triggers an action. So it means that maybe a sale happened and it needs to trigger like the CI or the BI or the CRM tools. Any service, any application inside our environment needs to be aware that something happened somewhere in our environment. And that being said, I mean, that's the general idea of event-driven architecture. So trigger an action when something happened and not the other way. And I think the Doordash or any food delivery, any asynchronous application really emphasize the need for it. So let's say, for example, someone is waiting or created an order or something like that, and is waiting, he has a spinner on his screen and is waiting for the restaurant to respond for it or to reply with order completed or order delivered or something like that. So while he waits, something happens asynchronously in the background. And I think that this is really emphasized the need for event-driven and real-time architecture. The user on the other side, the producer that produced the event can wait while the consumer at the other end are able to perform it and not keeping wait while wait for his event. And so let's just deep dive into FastMart. FastMart is our Doordash-like application. I use the technology stack below. That's like questions. Some push messages on the side. So I've used Node.js as the language that I programmed the application. MongoDB for application state. Memphis as our broker, and Kubernetes as the environment that the application runs on top. A quick note about.
Sorry, just quick question though.
Please.
Regarding MongoDB, is there any preference towards that? Are you just more experienced with that, or is there something specific about it that gives you an extra advantage when building this app?
So MongoDB, I would say it became our first choice out of our own familiarity with Mongo. Mm-hmm. It's not a very classic database to run on top of Kubernetes. If that's what you meant from your question, Bart. But I would say it's very easy to build your app around it because you're already familiar, and it's worked great with Node.js. So we wanted a quick time to market regarding building the application fast.
Yeah. That totally makes sense. No, I mean, I understand. Like, there are a lot of databases out there. If it ain't broke, don't fix it. If you're comfortable with one. And I think that's once again for a lot of people, because which databases should I be running on Kubernetes? We've had talks about Cassandra, about Postgres, et cetera, but totally makes sense there. Anyway, good. Keep going.
Definitely. So MongoDB, Memphis, and Kubernetes. One hint about message broker, and not particular Memphis, but just the idea of a message broker. So as you can see, like in the picture below, a message broker, sometimes people tend to think it's a pattern, it's an architecture. So it's everything combined into a technology. The most popular one, probably Apache Kafka and memphis.dev as well. So the core essence of message broker is basically in the very basic form, is to create an asynchronous communication between different services or different applications. And so instead of an application communicate directly with another application or a different service and wait to his response, it's been done asynchronously. So application one just throw a message, throw an event to the message broker, and then application 4 and 5 just consume it and perform some operation. And application 1 is already released from that point. I mean, the acknowledge is received by the message broker itself, and not application 4 and 5. It really gives you a boost. I'm about to release an article of why message broker is so important. I would say developers usually will come to that point. They implement message broker a bit late because of the entry barrier that can be complex a bit sometimes. But if you are able to overcome the complexity or the learning curve of inserting message broker inside your architecture, you would see that along the way, the complexity of your entire application is really lowered down. And that's a 1 minute about message broker. The most popular ones are Apache Kafka and messaging queue, which is a bit different pattern, but RabbitMQ as well, and of course memphis.dev. And we would love memphis.dev is also an open source, and we would love any contribution and engagement with our GitHub repo. So a bit about our high-level plan and how to start up FastMart. So first we will install Minikube. I already installed Minikube. It takes a bit longer. I hope that everyone that's watching right now or try to perform the workshop alongside with us already installed. But Minikube is just a sandbox of Kubernetes that can run on top of Docker or any virtual environment that runs on top of your laptop, but actually just create a simulator of Kubernetes with all its features. We will install Memphis over Minikube, clone FastMart GitHub repo, so we would have all the dependencies and code needed. And then hopefully we would be able to order some food. So install Minikube. Let me just quickly start my own. Bart, in the meantime, any question from the channel or something?
Also, you're talking about Kafka, and it's interesting to actually take a step back, because you're speaking of streaming. 2 years after we got started, it's interesting to see how the data on Kubernetes stack has been building out, because originally very heavily focused on database and storage, but now seeing these other kinds of use cases when we're talking about ML workloads, AI, and data streaming coming into the game as well. We've had different speakers speak about Kafka, Pulsar, Red Panda. I think we've had a speaker as well too from Confluent. Is this something that you think that we can expect a lot more attention on in the coming 6 months to a year?
Definitely. I forgot to mention this one, and the most important one, actually, data streaming and rhythm. We are just seeing the foundation or the starting of it. So and what I mean is that data is growing, and the old ways of doing like batch jobs, post-processing, it can take you till a certain point, but then from that point, when your data is not that grow but is complex and is distributed, then you will need to create some manipulations and start to analyze and collect your data via streaming algorithms and streaming methods. So that's why Kafka, which already born on 2011 and Pulsar and the other technologies, actually just starting to reveal its true power. But yet it's written in Java, which I don't have anything against it, but taking Java on top of a container inside the Kubernetes, we are not there yet in terms of stability, in terms of doing an abstraction on top of an abstraction. So virtualization inside virtualization. But definitely we would see more movement towards data streaming on top of Kubernetes, because Kubernetes, it's the new virtualization layer, right? That's the new runtime. And so definitely everything that we do on top of bare metal, we should be able to do on top of Kubernetes. So definitely, I think that we will see more and more technologies there. I have to add one more thing.
Okay.
Regarding that, that the main challenge at the moment, as I see it, do this movement towards Kubernetes, I think the storage layer underneath, definitely something that someone needs to raise the glove and gives us a proper distributed storage underneath, or shared storage on top of Kubernetes, beside the usual like Ceph or the abstraction layers on top, in order to really bring mass of data and more stateful apps on top of Kubernetes. So I think combination of both of them will really take Kubernetes to somewhere else.
That's a great comment. And actually, I'm probably going to pull that as a quote video, because we have quite a few folks that are in the storage space in our community. And it'd be really interesting to get a conversation started about that. So that's great. Anyway, cool. Keep going.
I'd love to speak with them as well.
No. We've got plenty of folks that are in the storage space. So I think it'd be really good to get that on the open. Awesome.
Amazing. So going back, just checking if my Cube CTL. So I'm not sure the entry point of the amazing people that are watching us right now. Kubernetes, it's not something that I can really explain in a second. But stop me on whatever command I'm running that is not really clear what it's all about. So I'm just displaying my namespaces to see that the Kubernetes started. And now I will install Memphis on top. So in our website or GitHub repo, you can see both of the commands to run over Docker Compose if you prefer to just run it on top of your Docker engine, your local Docker engine. Or if you have a Minikube or a Kubernetes cluster, you can also run it on there. Let's quickly install Memphis. And Memphis installed. Let's just see if everything started. So Memphis is going to be our message broker, that really makes the magic of asynchronous messaging or asynchronous communication between different services. We'll just wait for Memphis to start all its pod, and maybe it's a good time to just quickly view the notes of the installation. So if we want to expose the UI, we will just copy and paste this command, which basically port forward the UI through port 9000 to us. And if we would like to interact from our local machine towards the broker, towards Memphis broker, we'll just need to run this command and push the data towards that port. Underneath, we can see our secrets. So root for the username, root password can be revealed through this command, and the connection token as well. As you can see in the command that I've ran, and I already set the connection token to some custom connection token that I've used in FastMart. So I think that we are set up regarding this one. Awesome. Let's now clone FastMart repo. So I already cloned it. Let's go quickly over the different how am I with time? Okay, so let's start with order service. That's basically the front end where the client is actually interacting with the system. So the user sends a post command to the order service, which basically parse it and push it towards Memphis. We will see it in a minute. Oh, good, I have the architecture in front of me. So the client basically can get an order, get the menu from the order service, or post an order to the order service. The order service will place a pending order inside MongoDB just to persist the data, because something can happen in any message broker communication or in any REST communication. Something can happen inside the traffic between the order service, between the service and the message broker. So we always prefer to persist it somewhere and create a checkpoint. The order itself will come into Memphis station. So basically a message broker, if we use the term topic in Kafka or queues in RabbitMQ, so Memphis has stations. So basically, we will want to separate stations between different usage. So we have a station for ingesting orders, and we have another station for notifications. And the order stations, both services, email service and restaurant service, consume data from it. And notification stations, we have only the email service that consume data for it. And why the architecture is as follows, because we want to create a single station, a single notification station for our entire environment, for the rest of the applications inside our organization, and not just particularly create an email service or a notification service for each app individually, because it's just rewriting the same code. So this is why it is as follows. So basically, after the order is being consumed by the restaurant service and the email service will notify the client that the order is received and will be processed by a certain restaurant, and the restaurant service will actually consume the new order and start performing the dish itself, and then change the same order from pending to a different status, meaning that it's on preparing. So that's the REST API. And then I just wanted to give each of these services, as you can see, like email service, order service, restaurant service. I just wanted to give like a special place inside the architecture to reduce noise or cognitive noise from it. The connectivity to Memphis itself, which is again the message broker, you can find inside source services and MQ service. So inside the MQ service, we can see like the connection for each service, or for each, if I will take it to Kubernetes terminology, for each pod, we have a single connection. So as soon as the application start up, it will connect to Memphis and start a socket. But inside our app, as you can see, we have the producer, and we can also create several producers and several consumers. So it means that, for example, if I'm adding Bart to email service, inside email service MQ service file, you would be able to see 2 consumers, but only 1 connection, again, as I've explained. And then we can see some middleware that attach some functions to any events that ingested inside Memphis, and that's basically it. Simple as that. Let's maybe quickly go over the file tree. For example, order service. If anyone likes my terminal, I can definitely send a tutorial for it. I'm a huge fan of cool terminals. So
I know, I think visually speaking, yeah, that's not, I don't think I've ever seen one like this before.
Took me a while to modify it.
a little bit of developer experience goes a long way. Yeah, no problem.
Definitely. So as we've seen, just again, the connectivity to Memphis, so Memphis host, if we're manage it locally, it would be localhost. The user that we will use, FastMart, and the connection token would be Memphis. But if not, let's see the Kubernetes deployment file. And talk about this one a bit more, about how to take an application and deploy it over Kubernetes. So for some people that joined us, I think that looks a bit like gibberish, and I completely agree. It takes a bit of a learning curve to understand how to approach a YAML file, but I can promise you that as soon as you starting to write it a bit yourself and understand the different syntax and the different rules, it's definitely becoming a second language. Let's quickly understand it and the different layers that inside the Kubernetes deployment. So as you can see, we're starting by creating, sorry.
YAML, no, YAML as an acronym, do you agree that it's yelling at my laptop?
Nice.
No, I heard that. I heard that in KubeCon. So it sounds like it, yeah. But like you said, once you kind of learn, how to get around it, then you can really extract more value from it and not just see it as something that's overwhelming. Correct?
Definitely. It's. I have to say that once you understand or get the different building blocks of Kubernetes in your mind, it started to become logic as you proceed. You understand the different layers until you get like the container itself on top of the cluster. But again, it just requires practice. So let's quickly understand the different layers inside the Kubernetes file. So I always like to place everything at the same file. For me, it makes sense to like see the entire layers. And as you can see, we start from a namespace. And if I have to equivalent it to something else, so that means a quota. So that means like a separate or private place just for your app on top of the cluster, and gives you a lot more flexibility in terms of quota the resources or just managing your entire application dependencies in a single place. So that's namespace. We're creating our FastMart dedicated namespace. Afterwards, we can see the service. And a service is attached to a certain deployment or a pod based on the selector that you chose below. Now, a service, as I understand it, or as I can say it in simple words, it's basically a load balancer. The beauty in Kubernetes, as I see it, is the ability to scale our app really, really fast, really, really easy. And we need that something in front that will allow us to abstract the communication or the request between outside the cluster and onto our pods, which you can see just for the simplicity of things as a single container. So service is the load balancer that goes in front of the containers. And underneath, as we go in deeper, we can see deployment. So basically, deployment, I will keep it simple as possible. Deployment, it's a package of pods, and that basically make sure your pods is always alive. And if something happened to a certain pod, it gets them restarted and defined by the way you define the deployment. So no matter if you have like 20 pods of the same deployment, they will all be with the same configuration. Underneath, we can see the environment variables that I've shown before, like the Mongoose. The Mongoose, by the way, we're not starting our own Mongoose because Memphis itself use a Mongo inside their deployment. So I figured out why to create another MongoDB. We can just use Memphis, and here we can see the URL inside Memphis. So basically, it's an FQDN. It's a Kubernetes FQDN. So let's put it this way. After we developing on top of our local machine, we want to take and wrap our application and put it inside or on top of our Kubernetes cluster. And the communication should happen internally and not from our local machine, but either but from within the Kubernetes itself. So that would be the FQDN. That one is always always constant, and this one would be the name of the service, which we can see at the service up top. And Memphis would be the namespace, which is the namespace of Memphis itself. So we can see the name orders. And awesome. Image is the image of the of FastMart itself. And at the moment, it's hosted on top of Docker Hub. But that basically it. And just a quick sentence about how to take the app that you developed on top of your local machine and put it on top of the Kubernetes, on top of your Kubernetes. So basically the steps would be create a Docker file for each service, build it, push it towards, it doesn't have to be a public registry, but just for the simplicity of things, we would use Docker Hub as a public registry, and then create a YAML file for Kubernetes, tells him what do we want to start, how it should start, with what preferences or settings, and which image should be pulled. So it's the same image that we built and pushed towards Docker. So let's see if we're in business and start.
Sorry, Yaniv. We got a question. Someone he may have arrived a little bit late. So would you mind just quickly summarizing what's the role of Mongo in Memphis? If you can just reiterate or just kind of cover that quickly.
Awesome. So basically inside Memphis, there is a UI and there is a management wrapper around the broker itself. So at the moment, we are using, and it's about to be removed in the coming version. We are switching towards distributed key value store inside our broker, but at the moment we are using Mongo just to maintain application state and only for the wrapper or the management wrapper around our broker and not for the data itself. Hopefully I was managed to answer properly.
Yeah, I'm sure that's fine. If not, Divine can follow up with us on the chat.
So we applied our Kubernetes deployment of FastMart. Let's quickly understand if everything started. And we have an issue. Let's see what it is. Memphis user does not exist. Okay, so just to quickly understand which user is Memphis username should be FastMart. Okay, the initial user that Memphis starts with is root. And if we want to use a different user, we should create it as well. So let's quickly expose the UI and create another user. So as you've seen, I'm just copy and paste the command. And the password itself. Broken pipe here. Okay, so I'm inside Memphis UI, going towards users. Just quickly remove this one. Add new user. Let's call it Memphis as FastMart. Sorry, FastMart wanted Memphis, or No, it requires FastMart. Awesome. So let's call it FastMart. And we have two types of users, so management or application. Management would be just for management, and application would be for applications that wants to interact and exchange data with Memphis Worker itself. Username FastMart, connection token Memphis as I've defined in the application itself. Going back to FastMart pods, let's see if they succeed to starting up. We will quickly remove them just to give them a faster restart. And hopefully, I would not get a huge lapse. Awesome. It looks decent. Okay. So going back to the article, we basically accomplished this one. So at the moment, order service is up, restaurant service is up, email service is up. Both of them, oh, we can still see it in, awesome. We can see both stations. Factory is just a wrapper around stations. And we can see both orders and notifications and stations. Let's quickly go to orders. Great. So we can see our producers, and we can see order service, and we can see our two consumers, so email service and restaurant service, which is exactly like the architecture here. So email service and restaurant service are up and running and waiting for some order from order station. And we have also notification station, which should have only restaurants and emails. So basically that's this one, restaurant service that push data or push notifications toward the notification station, and email service that consume it and notify the client. So that looks good. Let's quickly run a kill command. How are we with the time? Awesome. Let's see this one going down. So everything I've did can be found inside the article itself. Minor change, we use the CLI to create the user inside Memphis. And let's quickly expose the order service, which is the front end of our FastMart Doordash application. The thing that I'm doing right here, the port forward, is basically to expose like internal services inside our Kubernetes cluster to my local machine. So I would be able to interact it or develop it and develop on top of Kubernetes, but from my local machine, instead of like for every single change or every interaction that I require to do, I would need to like build the image, push the image, apply the YAML file, etc. So we're exposed to FastMart order service. Let's see if it's alive. That's always the exciting moment to see if your demo is okay. And it works. Awesome. So basically here, there is no event-driven magic. Here it's just us, our client, us as the client, us as the client, asking the order service to get us the menu. So strictly straightforward REST API communication. But now we want to post an order, and that again, order will be inserted into the order station, will be inserted into the MongoDB as well, and then the entire flow, but event-driven style. So I will take the command from here. As you can see, we have some burgers, we have some fries, and we have Coke. Now I will take the post command. Maybe I'll create a side-by-side screen just to emphasize the flow of the data. 1 second. So that's Memphis. Let's quickly show orders. Awesome. So basically what we can see right now is that order service is connected to the station, and consumers are also live and connected to the station as well. And when sorry about that, copy and paste the issues. Let's quick change this one. And if our post command will be succeeded, we can see a message that goes through from order service to the station and consumed by email and restaurant. And basically, they will perform their action based on that order. Great. So awesome. We can see the message that we just sent, and it produced by order service and consumed by email service and restaurant service as well. Let's see if we have some logs to it. So it received the order, but because I didn't connect any Gmail account or something like that, it was not able to notify me as the client. But if we will go into select restaurant service, it would be much cleaner output. Awesome. So order with a MongoDB hash ID accepted and then delivered. So that's basically it. That's FastMart. And I would love to spend the rest of the time in this session to just discuss event-driven, discuss Kubernetes, discuss data streaming on top of it. Any question that I can help with, I'd love that.
Okay. When we talk about a lot of these things, we go from what's being done previously to what's being done now. Points of resistance, whether it's legacy systems, monoliths, et cetera, in order to get folks out of that sort of comfort zone, what do you think are the first steps in order to make it easier for that to happen? Because as much as we talk about technologies, at the end of the day, a lot of this is about change management. So let's say there's a large scale organization that happens to run delivery services. How do you get those conversations started with the engineering team? How do you show the value of showing us what you just did in the demo? How do you approach that?
So I'll demonstrate actually with the struggle that brought me into event-driven. So basically, me and my friends and future to be partners or current partners that helped me, that together we built Memphis. Actually, we started building an open source project regarding analyzing social conversations using AI models. And it worked great, actually. Like every open source dream, like immediate traction. People were using Makela, which is a Hebrew word for chore, and actually loved the product. But then we started to get feature requests asking, please scale towards or allow us to add more data sources like Telegram, like Facebook, like Reddit, like any and like more sources. And then it hit us. Well, we understood that we don't have a framework that can support such a scale. So we needed to disassemble the entire architecture and put something in the middle that will allow us this agility, the ability to change microservices and not disrupt the others, the ability to add more services in parallel to the current one that are already alive. And then we understood the power of message broker, not like in the general idea of it, but then we understood what is the power and what it allows us to do. Now, having said that, many startups or many organizations, many developers reach to the very simple point to prove their idea, right? We want to achieve proof of concept as soon as possible and not thinking about scaling and robust architecture, stuff like that. But I think that even for those are, and it's perfectly fine, but I think that even for those architecture, if you understand the real value that creating a message broker based architecture and the value that it will give you in the near future, like the amount of complexity that it will remove or offload from you and the rest of your team, I think it's worth the learning curve. It's worth the refactoring, and at least worth considering. And as a developer, I started using Apache Kafka, and we wanted to implement Kafka inside Makela, the open source project that we've built. But the entry point or the learning barrier was too high for a team of 4 people, and that's what really brought us to build Memphis, to try to lower that barrier. And there is some other great projects like Pulsar as well that doing a great job, and open source as well, of course. They're doing a great job doing the same thing on top of Kubernetes and on scale. Definitely, I think it's just a matter of adaptivity and willing to leave the monolith on the side for a second and try to widen your perspective and think a bit longer, a bit to the future.
I like that. And it's interesting because a question that we frequently ask our speakers is, why should practitioners, engineers be taking the idea seriously of running data on Kubernetes? And there are different answers, but generally it's going to be one of the following. Cost. It can be, a question of talent. Do you have a team that's ready to do this? Can they build an operator? Will they know how to use one? If not, all those different things that can come into there. Then another factor as well too, and I believe it kind of goes along with what you're mentioning, is leveraging Kubernetes built-in features. And particularly in this case, I think what, for me, the takeaway that I've got is regarding scalability, that you just can't get that.
Definitely.
And particularly in the cases, like you said, from the pain point that where you'd realize like, oh, we need to get all these different data sources from the previous project. And then in this case, if we're thinking about a delivery app, if we're thinking about e-commerce, if we're thinking about an autonomous car with all the different data points that it has, when it's on, it's generating tons of data, and when it's off, nothing. So I think these things definitely come into it. Would you agree, though, in terms of the reasons that folks should be keeping in mind for running data on Kubernetes?
100%, and I'm pretty sure that if it's not happened till today, it will definitely conquer the entire runtimes as we know them. And for one simple reason, by the way, history teaches us that from the moment, I would say around 2012, VMware started like the real movement towards virtualizations. And everyone says it's great, it's awesome for web apps, but it can never run databases. And then like the first one made a move and starting to move more workloads or more heavy workloads and stateful workloads on top of virtualization, and all of a sudden everyone does that. And I think that's the same, that would be the same case with Kubernetes. It's just, I would say, if we would be able to bring it closer to the average developers and remove the fear a bit that it's so serverless, you're not sure where your data is actually sitting at, and the entire it's the beauty and the curse of Kubernetes, the entire like stateless behavior that your application can just run anywhere and you're not sure where it is. I think when we would feel more comfortable about it, definitely we would see more stateful workloads moving towards Kubernetes.
Good. And we do, like we see it more. This is, like I said, we're almost at live stream number 140. We've done 3 DoK days. There's been plenty of activity going on, and seeing from different practitioners such as yourself from all over the world, that this is being done and there is a certain amount of value being provided here. Going back to this, you mentioned VMware in 2012, and previously you had mentioned, like Kafka, technologically speaking, is relatively old. I know they just had the OSS, summit in Austin. So people were talking about, how Linux is, now over 30, but Kafka is not, straight out of the, fresh out of the box, or whatever we want to call it. Like it's not terribly young. And I'm not trying to pick on Kafka. It's a great technology that provides lots of value to many people. What I'm saying here is that whether it's Kafka or other technologies, the challenge becomes with Kubernetes, and there are different success stories, and we can look at different things. But one of the things that seems to be problematic that's mentioned time and time again is the nature, to what extent a technology is Kubernetes native or Kubernetes flexible or not. And then the certain challenges that what we kind of say in Spanish, at least, that you have to shoehorn it in or like kind of force it in a way that's not necessarily comfortable. Do you imagine that technologies such as Kafka will eventually become more and more outdated, or they're just going to need lots of additional support in order to be able to run on Kubernetes? We've had plenty of talks, and we actually have another talk this week about that specifically, also with someone who's in the Strimzi project as a maintainer. But do you feel like the Kubernetes native technologies are going to be better positioned as more organizations move on? Or that it's like, well, we've used Kafka, and now we also want to use Kafka on Kubernetes, but I'm not interested in using something new. How do you think that's going to go?
So I would say the newer players that took the core of Kafka, refactoring a bit, turn it into maybe C, like Red Panda or Strimzi, that were able to manipulate the core a bit and made it run like perfectly on top of Kubernetes. Those are the players, I think, that will continue this journey and take Kafka towards the edge and towards Kubernetes. I think Kafka itself, it is designed for robustness. I think it is designed for like heavy workloads that require particular memory management on top of bare metal. I can see at the moment like core Kafka becoming more cloud native, or I always say it's just not fit into a container. Like it's taking a lion and put inside like a 3-bedroom apartment. So it's just not fit there. It's great for different workloads. It's great for different environments, but it's not the right place to place inside a container. So definitely Red Panda and Strimzi, and of course Memphis, because it's written in Go. So definitely a compiled language instead of a JVM. So yeah, a compiled language compared to a virtualization one or JVM, definitely as its ability to adapt better for Kubernetes environment.
And with that choice as well too, because that's interesting, thinking about Go and thinking about your average Kubernetes practitioner, what are they going to be most comfortable with? What was behind the decision that we're going to use Go? What was the decision behind that? How did that get built?
So basically, we started as a fork of NATS, which is another open source project that basically created the core of Memphis, and we created our own stream. Go is really, really fast, compiled language as well. And if I'm comparing it to C, for example, the ability to code in object-oriented manner or via packages and dependencies management, I would say Go is much faster than C and C++. So definitely that was our main decision. And yeah,
it makes sense.
That's it.
As a when I was 10 years old, I was doing other things. I was not programming like you were. So but I always find these things interesting. And I've been told, and I'm not, sponsored by Go or anything like that. But what I have been told is that the simplicity of building blocks. And so often thinking about, coding for folks that may have an infrastructure background that aren't used to coding, things of that nature. So I do think that's interesting that you made that choice, because of the different stakeholders are potentially thinking about who's going to be using this and how can we, once again, going back to the human elements, how can we empathize with those people and remove, unnecessary suffering from their work lives. So I like that. I think that's
definitely,
that's a cool choice. This is
good.
Yeah.
And we are Kubernetes first. So we didn't have any idea of going towards bare metal workloads or bare metal environments or runtime. We were Kubernetes first right in the beginning. And so the comparison or the benchmarks that we did was Rust, Go, or C++ and Go 1.
Okay, all right. That's great. I think we're just about out of time. Yaniv, is there anything else that you'd like to share? Anything that we haven't covered? Is there something that we've missed? Are you writing a book about how you've been programming since you were 10? A documentary, anything?
No, actually, just to encourage everyone to like find a project, find an open source project, find a community that you like, engage with it, contribute to it. Memphis is always welcome new members to its project, and again, just any community. I've learned a lot, and I think that brought me to a certain experience. Like open source brought me to a certain experience and learning that I don't think that I would get without. And thank you for this opportunity to contribute some knowledge to anyone in the world. Thank you for that.
Thank you. I think you said everything that we've been trying to express to people, but in a much more succinct and eloquent way. Get into a community, get out there, get involved in something. I think that's and the best way to get involved is to get involved. And it's really nowadays in 2022 is not that difficult. There's tons of places out there. Find something that works for you. Before we finish, we do have a tradition in our community that while our speaker is giving their talk, we have an amazing person from our team, and his name is Angel. And he was drawing an artistic depiction of the things that you were speaking about in your talk. So we have a mixture of things going on here. We've got the delivery bicycle. It's getting delivered towards the person who wants their order. And I think it turned out quite well. So we'll be sharing that in Slack. It's always nice to have a sort of visual representation, artistic representation of things that were discussed. This was great. And I encourage other speakers as well that are going to be watching this. Get a practical example, so something we can all relate to. You know, what could be more nowadays in 2022? Who's not getting something delivered in one way or another? Thinking about these practical applications and the things that are going on behind the scenes. So anyway, Yaniv, thank you very much for your time. I will say this as well too. Following up on a point that was mentioned earlier, if you joined late about 45 minutes ago, Yaniv was talking about, the interest in digging a little bit deeper on the storage side of things about what are the best options. Is it an area that's quite, traditional? Is it an area that needs to be more modern? What are the things that are happening there? We've got quite a few storage folks in our space, and I think that's going to get a really good conversation started. So I look forward to that and interacting with you more in Slack. Thanks everybody for joining, and we'll be seeing you soon. So take care. Okay.
Thanks, Bart.
Bye-bye.